Right, let me start recording and we can record from now. All right, good. So in Octave, the help section is right help, and then you click documentation, and then you click on disk or online. I'd recommend online, right? So you just click that, or you can click on disk if you have it, right? So what that's going to take you to is just a website with there's a lot of different topics that you can look up, right? So let's say I taught something in class, but you didn't really understand. It's like, sir, I didn't really understand what sir and teaching me. Come on, it's only confused me. Let me go see how to do this thing back, right? So you can come in here and you can look for the topic, right? You can look coming here, something from maybe the introduction section, something about creating a matrix, and you can click that. And here, what it does is it gives you all the codes about creating matrices, right? It says things like A is equal to 1, 2, and it has a semicolon. And it tells you how to create the matrix. And it just has a lot of information here that you can read and learn yourself. It talks about matrix arithmetic, multiplying 2 by A. What does that do? Right? And things you can try out and learn on your own.
Excuse me, sir. I just got clicked out. Are you still on the question mark thing?
Yeah. So we're looking at Octave, and we'll look at Matlab in a few. And there are lots of other things, right? So let me see, maybe no variable expressions function. Okay, so terminal output. That's like remember we were doing this printf thing, right? We were saying printf. Then we put some
fprintf.
Yeah, file printf, but let's just do this one, right? And that prints hello, and we do like the backslash, right? And so they're like very small differences between printf and fprintf, right? But as I said, the F here stands for file, and printf, well, print stands for print, and this other F here stands for format. So it's just a formatted print statement where you can put things like this backslash n, and you can add another variable. Like for people that have coded before, you know how format print statements work. For people that haven't coded before,
Yes,
don't really worry about it. Just know that if you use whichever one, you can do stuff like put stuff out to the command window, right? Yeah.
Sir, where is the question mark in Octave?
Yeah, so it's at help here on top, documentation, and then you select online or on disk.
Okay.
Online is going to take you to the online one, right? So we can come in here, we can click input, output, terminal output, and see what kind of stuff they have. They have here a different command. They have this, and the value of pi is. So we can try that out in Octave, this open thing, and let's try our same word hello, right? And what happens is it does the same thing, but you see automatically it puts it in a new line, which is weird. When we did printf or f without the thing, it doesn't automatically put it in a new line, right? So you can come in and you can learn new stuff, right? You can learn different commands, different things, and you can try them out, right? So what this means is that you're not only limited to the things we learn in class, you can learn stuff on your own and you can add them into your program, right? So maybe in the plotting part of the last class, you were thoroughly confused. You can come here, introduction to plotting, see what they talk about, all right? A little bit, maybe two-dimensional plots. Click on that, and then you can come in and you can see, okay, they got this thing about creating the matrix, which you guys know with the colon and 0.1 spacing between, plot x, sin x, and you can relearn this stuff. You can look at the example, you can see what it produces, right, and different things, and you can see, okay, wow, this is right, this is a histogram here. So maybe you want to know how to do that and different types of graphs, and so on and so forth. You can see how do I change it from just a regular line to all these other different kinds of graphics and things like that. Right, and you can do polar plots. I think the Matlab documentation is actually slightly better than the Octave documentation. So let me look at that as well. So here, you just come to the site and you click category Matlab, right? Where about this? You can just click come down, maybe getting started, perhaps. Mm, 2D and 3D plots. And then of course it's gonna load up a similar thing, right? It's gonna go 0 pi upon 100 to 2 pi, 0 to 2 pi, y sine x, plot x, y, things like this, right? And you can run through and see they did another example with a dashed line, which you might want to learn how to do. They did a thing where you plot two functions on the same graph, sine and cosine function. And you can see how they do that. They tell you, they introduce this new thing, right? Hold on and hold off. Here, maybe you want to do 3D plots, right? And you don't know how to do that. Maybe you're in your maths class, you're now learning about multivariable functions. You learn about functions that depend on two variables, right? Partial differential equations, three-dimensional functions, three-dimensional scalar functions, three-dimensional vector functions, and you want to plot all these things. So as your needs evolve, you're not always going to want to plot flat 2D plots. You might want to plot 3D plots. And as your need evolves, Matlab can offer solutions to that, right? So, and you can just do a lot of things. It's just whatever you need to do, you can come in and just take a look and see if you can figure it out and try some of the examples. Just learn how to do new things, right? Additionally, you can always just Google if you don't know anything, like again with a plot, how to plot Matlab, how to plot graph Matlab, right? Or Octave. And it can take you to this tutorials point website which will guide you through, and it has solutions. You guys know how to do research and you know how to find things. So you're never limited to what you learn in this class. You can always go learn stuff on your own, learn from a different source, and increase your skills, expand your horizons, become more capable. Okay, so with that in mind, when you look at your assignment, know that you're not limited only to the things you learn in this class. Maybe you might want to do something fancy. Maybe your question requires you to use the exponential function, right? So we did sine functions, sine of x, right, in Matlab, but we never did the exponential function, right? So e to the power of something. So we can just Google how to do exponential function in Matlab, and you can find some kind of source and they'll tell you how to do that, right? You can go on the same MathWorks website and it'll say, okay, y exp to the x, that's the same as e to the x, right? Okay, so you can just learn how to do things. Whatever your particular question in the assignment might need, right? So those are just ways to find out, do more things. You can use the built-in documentation for Matlab and Octave, right? Pertaining particular to the programs, or you can just look for other resources online, maybe by Google, Bing, just regular search engines, or maybe even on YouTube, because I'm sure a lot of people make videos on how to do certain things in Matlab. All right. Okay, so on to this class. What I have planned for this class is this program here. So back again, we have some script open. Trying to zoom. Okay, No, so you guys can read this code. Let me open it up in Octave because Octave makes it bigger. All right, so now this here, again, 25 lines of code. You guys are totally confused. You have no idea what's going on. So I pulled this example from a textbook, and let me get that textbook open up. And I think it's about time I sent you guys a textbook. But the textbook I'm using, it's pretty difficult, especially with the examples that they use, right? So it's hard to find a simple example because I know you guys haven't done any kind of signal analysis or any kind of advanced fluid mechanics, things like that, right? You're still in first year. So the engineering examples that are covered in this textbook, you guys might not be familiar with, but I'll tell you it and you can keep it. And as you go into second year and third year and stuff, you can look back at it and it can offer you some kind of guidance on how to do things, right? Yeah, things like control systems, fluid mechanics, right? Heat transfer optimization, all these different fancy things. Let me just find this example where it is. So my mic's, yeah, sorry about that. I was talking and my mic was muted. So this here is just a program that does the animation of a slide crank mechanism. Again, let me run the program. Okay, what it does is just creates some graphics here and it shows the animation of this slide crank, right? There's a slider, there's a crank, and it shows the path it takes and it animates it. This runs a bit smoother on Matlab for me. Let me open up my Matlab. So let me run it. And now Matlab, it runs smoother for me, right? So essentially, that's just what it does. It tracks the position of all these things and it plots it out and it moves it frame by frame. So how do we do that? Let me just start explaining the code, explaining the process, how we go about doing something like this, right? So first we need to look at what we want to do, right? So we want to animate this slide crank. Now, this here, this here is a slide crank, right? And in it, there's certain dimensions. So you're a mechanical engineer, you want to animate something like this, right? You want to track all the distances, you want to track the movement of this slider. Here, this block moving back and forth, right? You want to track how that moves. You want to track how this pivot point here moves around, right? The locus of this, you want to track something like that. And of course, you want to print out all the other basic things like this, just this line here, this block here, different sections. So all of that, they got dimensions to them, right? Right? So in order to do this, of course, you mechanics people know there's some formula towards this, and I won't go into how to generate the formulas for this, but the horizontal distance that the slicer moves is a function of angle and the crank arm A. So this here is the length of the crank arm A, right? And the horizontal position of this slider, so this thing here, the horizontal position of it is a function of angle, which is how this thing rotates, right? What angle it's at, and crank arm A, right? How long it is. Okay, and you guys can go about doing all the trigonometry and whatnot, or maybe pull this from a textbook, the equation, and figure out what these positions are going to be, okay? And you just get a formula. So what we do in Matlab is we set up some variables, right? Putting in all the dimensions, right? Things like E is equal to 0.25. That's the distance of this top here, where this slide rests. So the center of where the arm A is attached and it's gonna move around. And other things like C, right? C, which is the width of this slider, the height of this slider, or width, you can say whichever one you want, and D, which is the length of this slider, right? D. So you get all your measurements in place. Things like F was the thickness of this beam part here, or this horizontal part here was the thickness of that. Of course, you have your length A and your length B, and S, which is based on a formula, right? And then you start thinking, okay, how do I program this in Matlab? Well, what you're gonna first need to do is print out this thing stationary, then maybe stationary how it is right now, like this, right? You first have to print that out stationary, then do some calculations, right? Calculate for the new position, the changes in A and B, the arm, and then print that out, then do some more calculations at the new step, and then print that out, then do some more calculations at a new step, and then print that out, and so on and so forth. Right? And then you run all that together, you do the first position, the second position, third position, and eventually it starts looking like this thing is animating, right? Like it's moving like this. Just look back at it one more time. Okay, just animating, just moving around like that. So a lot of things are changing, right? The length here between this center point and A is going to stay the same, and between A, the end of A, to the middle of this slider are going to stay the same, but this slider is moving and the positional point is moving, right? So we can make adjustments to our code to facilitate things like that. So now let's look at the code. So inside our code, we have all the different things, all the different variables, right? N is equal to 80. We'll discuss what N is later. We have phi or phi, which is our angle, right? This symbol here in our formula is called phi, right? And in Matlab, we just write that as phi. And we set the values to be 0 to 2 pi, right? Because 2 pi radians is a complete circle, right? 2 pi radians. So that's what we're doing here. Let me use this, make it a bit bigger even. So this line here, we're using that linspace command, which you guys remember from last week, 0 to 2 pi, and we're putting n spaces in between. So n is 80. What that means is just that we're breaking this circle up into 80 different pieces, right? Into 80 different pieces, right? Here, 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 here. And we're going to do calculations for each one of those positions, right? We have a formula here, and we're going to do calculations for each one of these positions. Okay, so back to the code. So that's that line. We have the different dimensions we need, right? A is equal to 1, B is equal to 2.5, E is equal to 0.25, right? We start plugging in our dimensions or different variables, right? E here, the length of A, the length of B, C, the length of C, D, the thickness here, S is based on a formula, right? So we start creating a variable. Phi, right, is a value that's changing because it's moving around, right? The angle continuously changes. So phi changes. Okay. Now we put all those in, right? We say two other things. Yeah, right? You put all those in, A, B, E, F, C, D, which is 1, and F, which is 0.6, right? And we put in S, which is of course this formula here, right? So AX is A cos phi, and AY is A sin phi. So back to our formula. Our formula here is essentially A cos phi and A sin phi. So what we do, we create some new variables, AX and AY, and we kind of use that to help simplify the expression, right? So that's what we do here, right? AX plus the square root of B squared minus AY minus E to the power of 2 squared, right? Which is essentially just this formula here. So we input this formula into Matlab like this, right? And then we continue and we go about plotting our graph, right? Good. Now, this code here, let's ignore that. And let's look first at this first command. Okay? We see a command, fill xgnd yndr. What does the fill command do? Well, we can just Google it. Say we run to Google, fill, what does fill do in MATLAB? Fill in MATLAB. We can find some instructions, see is a fill 2D plot polygons, right? And we can read all there is to know about the fill command, right? And see what really goes on. But I already have a script worked out as the fill command for you guys, just to make things easy. And I'm gonna run it. So we have some vertices, some array of points, 0, 0, 0, 1, 1, 1, 1, 0. It's just an array, a 4 by 2 array. And we have something fill, some stuff here, and then some stuff here, and then this tag R. So what does that do? Let's ignore these two lines here at the bottom. Let's comment this out. We know what axis equal does. Axis equal adjusts the aspect ratio. All right. Okay, so let's run this. What happens? You see it plots up this square, just a big red square. So let's look back at this command. It says vertices :1, vertices :2. We know this colon represents this part. So when we are displaying an array, so let's say some array, and we put the parentheses, we can do something m and something n, where m refers to the row number and n refers to the column number, right? So here, what this specifies is column 1. So if we wanted the first variable, we do 1, 1, row 1, column 1. This variable here, we do row 2, column 1, right? We do 2, 1. But what this colon does, you guys know, it refers to all the rows. So when I type vertices :1 like this, it spits out this entire column here, right? And when I do it with that, it spits out this entire column here, the second column, right? And then R. So let's change R to something like G, right? In this command, and let's run it. Yeah, this is not code. Let's run it now. Okay, and my graph is here. Now my graph turns to green. Okay, great. Let's go back into Octave. Let's change it to Y. Right. My graph turns to yellow. So we can start figuring out that, hey, maybe this letter here refers to the color, and these here, possibly, since the variable is labeled vertices, refers to the vertices, and this fill command creates polygons, right? Creates polygons based on these vertices that we give, these coordinates that we give them. And this here could be X coordinates, and this here could be Y coordinates. And turns out that's actually what it does, right? It creates a polygon based on the vertices. So the first row, 0, 0, right? Remember, these are your X vertices, your X coordinates, and these are your Y coordinates. And it's gonna plot based on how we order them, right? So first one, 0, 0. Let's come here and let's put this line back in. And you see that line affects how it's displayed with the just the gradation on the side and the additional space of the graph, right? So first here, this position here is 0, 0. I don't know how well you guys can see this, right? 0, 0, 0, 0. And then the next one, let me just close Matlab. And then the next one, 0, 1, right? You remember, first one is X, right? So 0, 0, 0, 1. Then the next one, which is 1, 1, right? 1, 1, and then 1, 0, right? Coming in here. So what if we swapped two of them, right? What if we just put this one there? Just swap. Just kind of made some stuff up. Let's see how it affects the shape. The shape looks weird now, right? What this tells me is that we need to order them in such a way so that it goes around and it creates a polygon, right? It moves from here right? It moves from here to here to here to here, and then it automatically closes itself, or you can put in another point back here, and then it's gonna create that shape and fill it. If you move from here to here, and then put something from here to here, it's going to confuse it and it's not going to create the polygon we want, right? So that's the fill command for you. And that's what it does. Now, here with this Y, G, R, and different things changing the color, we can just simply just go colors, MATLAB, and lead you to a site, the MathWorks site, or you can do colors Octave, right? Sometimes coding is just as simple as Googling stuff, right? Okay. And it'll lead you to a site, and here it has all the different short names, Y, M. M is for magenta, C is for cayenne, R is for red, G is for blue, G is for green, B is for blue, W is for white, K is for black, right? So all these different values, right? And you can research them on your own time and try them out and play around with the fill command. Right? So that's what the fill command does. Now look at this axis. Axis something, right? Let's take it off. That's right. Let me switch my things back. Have back my square, right? So here, the square is just automatically the axis units, right? From 0 to 1 defined. But if we turn this on, what happens is that the units here goes from minus 0.5 to 1.5. And the way we get those values from is because we tell it to do that. We tell it for the x coordinates, do minus 0.5 to 1.5. And for the y coordinates, do minus 0.5 to 1.5, right? And then it takes that and it just does that, right? So I'll send you this, you can look at it and you can play around with it as well. So back to our slide crack, right? Okay, so forget this 4 line for now. Forget these lines. We know, oh no. Forget these lines. Right, and we know these are just creating variables, right? And this 80 means 80 different spaces between pi. And these is creating variables and these is plugging in your formula for S. So the first command in plotting, fill xgnd, ygnd, r. So we know that that's going to create some red polygon, right? And it relies on 2 arrays, xgnd and ygnd. So like our own one, we had this array vertices, right? And it would use this column and this column. In this program, we use 2 separate variables. So that's probably just 2 different rows of your x coordinates and your y coordinates, right? So let's look at xgnd and ygnd. Okay, and let's run it. Now let's not run everything. Let's percent out everything else. Okay, and run it. Let's just run this part of the code. And what that does, that creates some square red thing, right? Now the square red thing, the square red thing is actually this long red thing, which is this here, right? This little piece of wood or whatever the mechanism that the slider is resting on, right? So if we go back to our textbook, the dimensions for that are f and some length here, the length of this, right? So in here, in ygnd, we have e, f minus e minus f, and e minus f here, right, for ygnd. And these are essentially just the coordinates, the y coordinates for this thing, right? And for the x coordinate, we have min ax, right? And max s plus d divided by 2. So what does max s mean? Remember, we're here. We created all the angles with linspace, and we calculated all the possible values between 0 and 2 pi for s. So when we say max s, right? Max s plus d divided by 2, what this does is it says, okay, what's the furthest back this thing can go, right? Plus d divided by 2, right? Which is d here, d divided by 2, which adds on this extra piece, right? Adds on this extra piece. And it starts to give us this coordinate here, right? And min a, remember this is gonna, min a cosine phi, ax is cosine phi. Let me clean this up. So let's say a, this is a circle. This is this circle here. This is your center, and this here is a, right? And a is up this way, right? Come down. Ax is here, ay is here. So ax is equal to cosine phi of a, right? That's down here. The min gives you the smallest value. So as this thing moves up, it shrinks smaller, right? As the angle changes, it shrinks to something like this, and it gets smaller and it gets smaller. So min ax gives us the smallest value this way. But when it comes past the 90-degree point, it's going to become negative, right? It's going to become some negative value, right? And then here, again, some negative value. Here, some negative. So the smallest value is actually this point here. And when we come back here to this graph here, that point there is somewhere around here, right? So the end. So when we do min ax, we're giving that end coordinate there. When you do max s plus d2, we're giving this end coordinate here. And of course, because a polygon, we also need both sides different points, right? And it's 4 different points, 1, 2, 3, 4. 1, 2, 3, 4. And these 1, 2, 3, 4, right? E and E minus F. So back to our thing, right? Remember, one is E. That's the top piece, right? So this here is your thing. Top piece is E, and the bottom piece is, remember this thing is F tick. F tick. So this part is E minus F, right? And you give your coordinates there. So you match your coordinates up, right? In terms of like what it would be in a Cartesian plane, and you plot them. The reason for this fifth variable is just replacing the first variable, right? So instead of us just giving 4 variables, we give 5 to close the polygon. You can do it with 4, which I recommend when you collect this program, try. But 5 is fine. So with 4, what you would do with the fill command is you'd get coordinate 1, coordinate pair 2, coordinate pair 3, coordinate pair 4. And then to close the polygon back, you'd have coordinate pair 5. So the program would go boom, 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 and close it. If we didn't put coordinate 5 in, it would just go boom, 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 and automatically assume, okay, I just go back to the start, close the polygon, and fill this up with whatever color they wanted me to put it in, right? So there, we made sense of these 2 lines, right? That's what these 2 lines does. It just creates an array of all the different coordinates. And R is the color red, so it creates that red box, right? Now, this command here, hold on, we can worry about that later, right? The next one, it plots AX, AY with this B dash, and at 0, 0, it plots KO, right? So what does that do essentially? So let's run some code. AX is equal to this, AY is equal to that. Let's take fill off. Move the slider. Plot. And we're looking at this line of code here. So what does this line of code do? Well, it's plotting AX and AY, and we know AX and AY are just cosine phi and sine phi. And we run that. And we see what it does is it gives us this kind of dashed line, which we know, we remember from running the program, is the circle, right? Is this circle here being traced, right? So that's what that line of code does. And now you understand what AX does and what AY does, right? Cosine phi, sine phi. The B dash means is dashed lines. But what does 0, 0 KO mean? Well, let's try 0, 0 K plus and see what changes, right? And run. If you look in the middle here, what changes is it changes from an O to like an X, right? X. And if you put it back again as O, it's gonna go back to an O. All right, it's gonna go back to an O. So that line of code essentially is just plotting two things together. So again, you can go into your documentation, look, how do I plot two things together? And you can learn how to do that. But essentially what we're doing is we're plotting AX and AY, B dashed, right, with dashed lines, and then we're going.
And we're not hearing you.
Yeah, hello, you guys still there?
Yes, sir.
Okay, yeah, my computer turned off a little bit. All right, that's a battery. Yeah. So as I was saying, we plot AX, AY, right, with B dashed, and then we plot another one, which is at the point 0, 0, and we plot just using O, just using an O, right? Now let's try putting this here as KO. KO. And run it. You see what happens is that it puts O's around the circle, right? So you can play around with them and figure stuff out. Right, so back to our dashed lines. So now we notice that it's in an oval, but we wanted it in a circle, right? And that's actually where this line comes in, axis off, axis equal. So let's just do axis equal and run. We see it moves from an oval to a circle, right? It makes the aspect ratio a certain way so that both axes are even, and it creates the circle, right? Which is what we want. And if you notice here, these points here are 0, 0.50, 0.5, 0, 1, 1, right? Those points are on, but we can turn them off by saying axis off equal. So what it does is it does two things. It makes it equal and it turns the axes off, right? The dimensioning off. So that's what that line is. And the rest of it is just more plotting stuff, right? So we do slider X, right? SK minus D2, we plot the vertices, right? And then we do another fill for the slider, right? So let's fill that, fill the slider, and then we run. Why is nothing showing up? And I accidentally commented something that should hold on. Okay, so we see everything start coming together, right? We plot the red line. We plot the dash with the O. And now the new thing is this slider, right? So this slider X thing, right, is the same fill command, which is the same way we fill the red part. We fill the red part, creating this polygon and filling it. So we create another rectangle here and we fill it. So back to our code. And of course, the code is a little bit complicated because they did their subtractions and stuff. And they found their coordinates, right? SK minus D2 for some value of K, right? So in this case, K can be set to 1, right? Because you remember, this slider, we can plot it at the 0th position first, right? But it's going to be moving, right? This red bar is going to stay straight, but this slider is going to be moving, right? So we're going to want to plot it for different values of K, right? And S is, of course, some function, right? And we're going to want to plot it for different values. And remember, we calculated theta values, right? So we're going to want to know what's it for all these different values, right? Good. And then there's just, what else is there? Slidery, which is just E plus C, E plus CE, right? The vertical component of the slider, right? Which is constant. So these here aren't going to change. Just the horizontal one is going to change because it's sliding from here to here, right? And that's pretty much it. Now, how do we calculate it for all the different values of S? Remember, S is from 0 to 2 pi. How do we calculate for all the different versions, right? Well, we use the for loop. So let me introduce the for loop. So the for loop is pretty simple. Let's say you have some code. You have some code, a line of code, right? And you want to execute it more than once. That code, you can put in a for loop. You can do for K equal 1 to 50. Then you do end. And what that does is it executes this code about 50 times, right? So you can do X of X is equal to X plus K, right? And what that's going to do is going to take X, add 1 to it, right? Let's say that's the line we're using. Then it's go around. It's going to take X, add 2 to it. And it's going to take X, add 3 to it, add 4 to it, take X, add 5 to it, add 6 to it, add 7 to it, right? So let's try something out like that. Here we have a simple one, dispello. Let's go to our command window. Let's clear it. You see, I'll see it. Let me just clear, clean everything up, and let me come to our editor. What I have is for X equal 1 to 5 is dispello. So that's just going to display the word hello 5 times, right? Let me run it a few times, right? And you see my program for a loop, when it runs, it does hello, 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 hello. Then when I run it again, it does hello, 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 hello. And it does that 5 times, right? CLC, let's do it just once now. Play. And it runs that command 5 times, right? So now, in your programs, when you want to do something more than once, you don't need to copy and paste it for this, copy and paste it for that, copy and paste it for something else, right? You can just as easily just use a for loop to do something that would be repetitive more than once, right? So you don't need to copy and paste the code over and over, right? Like this code here, for example, if we had to write it out, we'd have to do something like X equal X plus 1, X equal X plus 2, right? X equal X plus 3, right? That'd be confusing, right? It's like in mathematics where you want to do sigma n equal 1 to 100 or even infinity, but we might not want to do that in MATLAB. We might want to go really large, so we might want to go 10,000 or something, right? X to the power of n, right? And we can go ahead and generate the value. What's that going to output, right? So do x to the power of 1 plus x to the power of 2. And we can convert this to code and do some stuff like that. Although there are built-in functions on MATLAB to do specific things like this, right? But generally, when we want to run code repeatedly, we can do that using a for loop. All right?
So that's what's called for loop.
Yep, for loop. For loop. The general coding concept is loops, right? Loops. And the different types of loops. One of them is the for loop, and it's the most standard one, and it's directly translated to a lot of languages. In C, for example, we do something like for. So this here, the syntax is for k equal 1 to 50. If you want to do that in C, which is a different programming language, we do C, we do something like k equal 1, right? Semicolon, and then put some condition, something like A less than B or K less than or equal to 50, right? Which would satisfy this command. And then we do another thing like K plus plus, right? And then we do curly bracket. Because C is a slightly lower level language, and then we'd have the code in here, right? C requires us to use semicolons and curly brackets and all these fancy stuff, right? Essentially what it's saying that when K is equal to 1, and as long as K is less than 50, do this code, then add 1 to K, right? You can replace this with K plus 1. So it's going to go from 1 to 2 to 3 to 4 to 5, right? You can additionally do 2, which is going to do, increment by values of 2, right? And it's saying do that as long as K is equal to 50. So it's going to execute this a certain number of time based on this condition, right? So that's how it works in another programming language. In MATLAB, which is a very easy programming language, right? You just do for K equal 1 to 50. And that executes as thing as 1, as 2, as 3, as 4, as 5, as 6, as 7, as 8, as 50, right? So that's what we're doing here. For K equal 1 to N. N is 80. So what we're doing is we're calculating the position of the slider, this purple thing, for all the 80 different positions of phi, right? Because again, at the top, we did phi equal linspace 0 to pi n, and n is 80. Right? So we're calculating all the different positions, right? Let's leave hold on. Let's just plot this. Okay, run. Enter. Okay, good. So that's our for loop there. And what you see is it plots all the different positions, right? Plots all the different positions. Now, yeah, right? And it's still working apparently, right? Good. Now, these two lines here, this plot and this plot plots the two arms. So let's plot those. Right? You see all the different arm positions coming up, right? And it's gonna continue working, right?
Actually,
Right?
sir, notice I think it's above slide Y. You get E plus C like twice or thrice, and then you get E like twice.
Here?
Yeah.
So these are the coordinates, right? The coordinates
For
for
repeating, because you have to like twice, and the E repeated like 3 times.
okay. So these are the coordinates. Remember, The center of this circle is 0, 0. This here is position 0, 0, right? Remember we plot this with k is 0, right? With 0, 0, right? And we did positions, right? We found E, and this bottom coordinate here is E minus F, and you put the X and Y coordinates for this square here, and we fill it with apostrophe R, apostrophe with the fill commands, the X coordinates, the Y coordinates, fill. And we put that in and we fill it, right? So for the slider here, right? The slider, we do the same thing. So what's the position of the slider? Well, the position of the slider is E. The coordinate is E plus here, right? What's this value here? C, right? C. So this top coordinate here is E plus C. E plus C.
And then you're gonna go back to that point.
Right? E and E plus C. So here is E, right? E and E plus C. Remember, vertically, these positions here, right? Here and here aren't moving. Horizontally, it's moving, right? Right? But these here aren't moving, right? The X coordinates are moving, but the Y coordinates aren't. Right? Right?
I think I get it.
Yeah.
It repeats, go at that position like twice.
Yeah. So the square is moving horizontally, right? It's not moving vertically, right? So these coordinates don't change, but the X coordinate change, which we created as a function of K. And remember that value for K is going to go from 1 to 80. And we execute, right? So back to our diagram, right? You see how it calculated all the different positions, right? And all the different slider positions, all the different axes and whatever. And that's good. You might want to stop here, but just because it looks like a nice graphic, but it doesn't really give us any kind of information, right? Now, we want to introduce two things. We want to introduce pause 0.05. So let's look back at our for loop. Let's do this hello. Then let's do pause 1 second. 1. And let's run. In our command window, it's going to do hello. It's going to wait a second. We're going to do hello. So let's run it back for loop. It does hello. It waits 1 second, does hello, waits, does hello, waits, does hello. So this pause is essentially something that tells it, okay, do this calculation, print it out, then wait. Do this calculation, print it out, then wait. So let's unlock this pause in our thing, right? And this access command, we know that this just essentially sets up all the different the dimensioning at the bottom for the access, right? We went through that with a fill command, right? Like this. So I'll send this to you and you guys. So we can unlock those two commands and see how it affects the graph, right? So what's this? Okay, let's run it again now. Okay. So we see is that it waits 1 second or 1 unit. I can't remember what unit that the function takes in, but it waits 1 unit of time, some unit of time specified for the function before it continues printing the next one. So we can close it again. We can slow it down. 0.05 is pretty fast. Let's just do 1 second. Okay. And run. See, 1 second, wait another second, and then slow. It's very slow now, right? It's crawling. Okay. It's pretty slow, right? So let's speed it up back again. Let's do really fast. Let's do 0.01. Let's run it. No, computer's buffering now. think the old command is still running. Need to wait on this to finish. So we need to wait on the first aspect of the program to finish before I execute this one. Should be a way to pause this or skip this. Nope, and it's still running. Let's just wait for it to finish. Execute. Close it. Okay. So this is the newer one where we updated the time to 0.01 seconds, right? The newer one, which is faster now. All right. So now what we want to do is just minimize this while I talk a bit more about the code. So we calculated all the points, all the different positional differences, all the different slider positions. Now what we want to do is hold on and hold off. What this says is put your hold on, which is when you print this thing, let's take hold on off for now. Okay. And let's move hold off on. What this would do, let me copy and paste this code. Maybe in my folder. Okay, good. So what this does, this code here, remember we're not in the for loop anymore. We just, this isn't gonna work. No, that's great. Yeah, so hold, essentially it prints something, right? And then it waits on the graph for everything else to fill in. So in this case, what happens is that it does do the fill, right? It does do the dash circle, it does do everything else. But because when we print something new, when we plot something new, it erases the old thing that we're trying to plot. So let's say we put hold on, but we put it somewhere around here after the dash circle. Let's remove it from here. And we run this code. Check it. Dash circle, no, thin horizontal bar, X. Let's put hold on here. Okay, let's just take hold off while I troubleshoot. So let me use Matlab instead of Octave. Let me just write out what the hold command does. Okay. So since Octave is giving me a little problems, try and explain what a hold command does, I'll just write it out. So the hold command, right? Let's say we're plotting a graph and we do plot X, Y, and Y is sine X. And what this is gonna do is it's gonna plot your sin x function, right? Then if we do plot again, right? Plot x cosine x, what's going to happen is it's going to erase your sin x function. It's going to erase your sin x function, and it's going to plot cosine x, right? So let's try that. Matlab. Do a new script. Right, let's do x is equal to minus 10, 0.1 to 10. Right, suppress the output of that. And then we do plot x comma sine of x. And then we run this. Let's say if there's just a whole command. And it plots the sine function, right? Which we all know. Are you guys seeing the screen now? Yeah. Okay, good. So it plots this sine command, right? Here, good. Now if we did plot x comma cosine of x, and we run it, it plots the cosine function, right? But what happened to the sine function, right? Because we said plot sine x and plot cosine x, but two separate graphs don't show up. One graph shows up. And what happens is I plot sine x really fast, and it plots cosine x. And what happens is that we don't get a chance to see sine x. So what we can do is type hold on, and now it plots sine x and cosine x, right? So in our slide crank program, let me go back to Octave now. The hold on, that's essentially what it's doing, right? It's plotting that little square, right? It's plotting the circle, and it's saying hold. Keep everything on, keep everything on. And then when it reaches time to switch to the next slide, to the next frame of the crank, it's saying hold off, right? It's saying don't hold anymore. Do this, then print, right? So hold on. After we print that bar, we say put the hold on, print everything, all right? And then after we finish printing one of everything using k equal 1, then turn the hold off, which is going to clear the screen and print the new set of things, right? So let's run that. So what it does, it prints everything for one frame, holds, make sure everything shows up, prints everything for one frame, turns hold off to clear the screen, and then prints everything for the second frame, the second value of n, the second value of phi, prints everything, and then hold off, clears the screen, and prints the new stuff. So instead of us having it like this, hold off, run, which keeps everything on, we hold for only particular sections, right? We hold while we print one frame, then we turn hold off, we wait 0.01 seconds, and then we print a new frame. We turn hold on and off, holding the screen. All right, good. So now with Octave, because sometimes it gets a bit buggy, and when you're executing a program, in between, like let's say we execute this program, and I try to close this window, it's gonna pop up again. I try to close it, it's gonna pop up again, right? Because it's continuously trying to print the new frame, print the new frame, print the new frame, right? So you gotta be careful because Octave sometimes can stick like that, right? Right, but keeping that in mind, the rest of the code is straightforward, right? Just be careful not to run the program too many times. All right, good. So that's it. That's the functionality of how to do a slide crank animation. Right? Any questions on the hold command, on the fill command, on plotting, on axis off equal, on these different variables? Do you think if given enough time, would you be able to recreate something like this or a different question? Yes or no? How do you guys feel about this program?
Sir, can you go back to line 18?
Line 18 with slider X.
Yes, sir.
Okay, good. Okay, so after that, let's look at line 19 first. Fill slider X and slider Y, right? So slider X and slider Y, right, are the X and Y coordinates of the slider of the purple thing, right? So let's run it. And this here is a slider, right? This is the thing that's sliding, right? The X and Y coordinates of that. All right, yeah, and as I said with Octave, it's gonna keep running till the program's done, then you can close it. So you should understand that part, the X and Y coordinates, right? Okay. Now, because the slider is continuously moving, right? It's continuously moving, we're gonna have to calculate 80 different positions. We can obviously change this number to 40 and do 40 different positions, 30, 20 different positions, right? So what this line does, slider X, is for K equal 1, it calculates the position, the X coordinates, right? For K equal 2, it calculates the X coordinates and puts them into this function to be plotted, right? Calculates K equal 3 at position 3, right? So you remember again, the circle, we did linspace, right? Linspace, right? 0 to 2 pi, right? And we did n, right? 80 different spaces in between, right? So you got like 80 different angles within this circle, right? And for K equal 1 to 80 is going to calculate 80 different values for slider X, right? The X coordinates, the X coordinates, the X coordinates, and the X coordinates is an array, right? Because remember there are 4 points in the slider. So this is the slider, right? In this program, you can do it with 4 coordinates, but this program used 5, the program from the textbook. So there's coordinate 1, X coordinate. Remember, coordinate 1 is some X coordinate, some Y coordinate, right? Coordinate 1, coordinate 2, coordinate 3, coordinate 4, coordinate 5. Closing back the polygon. You can obviously stop here at 4, right? And the fill command will automatically close the shape for you. Right, so coordinate 1, 2, 3, 4, 5. So here, slider X, we have here coordinate 1, coordinate 2, coordinate 3, coordinate 4, coordinate 5, and those are the X values it's referring to. So S is equal to K minus D2, right? So minus D2 plus D2 plus D2, right? What does that mean? Let's go back to the slider from the textbook. So the value of S in the formula refers to this point here, right? Minus D divided by 2 gives us here, right? Plus D divided by 2 gives us here, and minus D divided by 2 gives us here, right? So we're essentially getting these coordinates here to plot here, 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 and here. And obviously, since this is like the x-axis, right? If this here is some point A, right? Here's going to be A, and here's also going to be A. Here's going to be B. This first one here is going to be, and this one's going to be B, right? So it's going to be A comma and some y coordinate, B comma and some y coordinate, right? And it's 5 of them, right? So back to the code. SK minus D2, right? Right, remember? Back on the graph. Right, your value for S is here, right? Minus D2 gives you here, right? Minus D2 gives you there, right? And then plus D2, and then the final one closing off the polygon there, right? So that's it. SK, right? Remember K is a function, and we calculating for all the 80 different ones in this function we plug into Matlab, right? So minus D2 plus D2 plus D2. And the final one closing off the circle, right? So 1, 2, 3, 4, 5, closing off the circle. And that's what slider X does. Now, you might be like, okay, why is slider Y so simple, right? Because if you look at this, right? Let's make this bigger, even bigger. Let's draw an x-axis. So now as this moves, right, these x coordinates are going to change, right? They're going to change and they're going to go back this way. So that's why it's S of K for the minus D upon 2, right? Or S of K plus D upon 2 for the various points. Now, for the y coordinates here, whether this box is here, or this box is here, or this box is here, the y values are staying the same, right? The y values are staying the same. The y values are still E, which is here, and plus E plus C. So back in our octave code, E plus C, C, which is the height of this box. Let me erase C, this C here, which is the height of the box. And E plus C, giving this point, this point, this point, this point, and back again this point, right? Closing off. So E plus C, E, right? Again, on the diagram. Here's E, right? E, here to here. This is 0, 0, 0.0, 0. E plus C. Here, this is CME, because BAM is a vertical coordinate. E plus C again, E here, this point here, and then back here, E one last time, right? And again, 1, right? 1, 2, 3, 4, 5. E plus C, E. And that's it, right? Because the vertical, it's not moving vertically, right? The slider isn't moving vertically, it's only moving horizontally, right? So the vertical coordinates stay the same. And we can plug that in as just slider y, but the horizontal coordinates change. Yeah, horizontal coordinates change. So that's essentially what's going on. Does that explain it? Or are you still confused?
Sure, so you basically just plot in the rectangle slider.
Mm-hmm. And we're plotting it at the first position when at that first, remember linspace breaks 2 pi up into, okay, let's change this here to 4. All right, 4. And let's pause 2 seconds in between. And let's run. You see what happens? So the resolution of the circle is kind of like a triangle now. So what happened to that circle is instead of creating a whole lot of points around, we only create 4 points. We do 1, let me look at this circle. 1, 2, 3, 4, right? We only create 4 points. 1, 2, 3, and then back 4, right? We only create 4 equally spaced things, right? So now in order to make it a circle, we're gonna have to add more into it, right? Add more, fill out the circle more. So let's make it, let's make n equal to 10 now. And that's not it. Let's do 1 second. Right? Or run into issues again. All right. Can I run it? So now you see the circle is kind of filling out, right? Filling out, filling out, filling out, filling out. That's just the resolution, how many angles we put inside, right? And then let's change to 0.5. Let's do 20, right? And you see it's starting to look like a circle now because we've increased the resolution of all the different angles in the circle. So it starts to look more like a circle now. All right. And then of course we can do our eta, which is very big. And we do that and we run and we get everything going on. And it's doing 80 different positions. It's calculating position 1, slider, filling it, slider 1, slider 2, slider 3, slider 4, slider 5, 6, 7, all the way up to 80, right? And it's doing all the different positions, right? Does it make sense? No?
Yes,
Right?
sir.
Yeah, it makes sense.
Good. So even if you don't understand everything, right? You at least have an idea what each line of code does. Axis off, axis equal, axis B, right? So you can collect the code. You can do what I did, right? You can put comments. You can comment off a line, right? You can change values. You can look at your workspace, right? When you run this program, let me window workspace, right? You can look at all the variables created, right? In your workspace. You can, of course, close off history, make your workspace bigger, right? You can examine these variables and really see what they're doing, what they mean. And you can try and make sense of this program, right? Use your comments. Just do a new script, type out some code, right? Copy and paste some code, see what this code does, what this code refers to, right? What this code is trying to do so that you can understand and recreate this code eventually, right? I know it's hard and it's a lot going on, right? A lot of different things, a lot of different arrays and stuff. But eventually, at least by the end of this class, the end of this semester, you should be able to look back at this, a fairly complicated program like this, and it should be easier, right, to understand. And again, you can always come back to the good old projectile program, right? Projectile simplified and look in and see, okay, we learned something new. I remember this end thing, but there is not for, it's if. What does if do? How is if different from for? You can go in help, you can go in Matlab documentation, you can search online if, right? If Matlab, if in Matlab, and read what that does, right? If is a conditional programming keyword, you can do your own research, figure it out, right? And come back in. Maybe you want to look for your for. Is for in your set, right? I look for all kinds of different things. I think in the big projectile program, there's a for loop, right? So in this one, at the end, there's a for here, and it does something, right? Remember this program, when we run it, let's just use these default values. Okay, good, okay. And it plots a different trajectory. So maybe in this program, they use the for loop. They say for angle at 10, for angle at 20, for angle at 30, for angle at 40, 50, 60, 70, 80, 90, right? And then you see, but sir, only teach we for k equal 1 to n. So that's going to give me for angle equal 1 degree, angle equal 2 degrees, angle equal 3 degrees, right? So how do I make that, right? How do I make that multiples of 10? Well, maybe you can do k times 10, and that's going to give me for 10, for 20, for 30, right? Maybe you can do something like that. Or, you know, look at the code. What did this person do in their code? When they did it for angle 10 to 10 to 90, right? You know what this kind of expression does, 10 to 10 to 90, right? You write that down. 10 to 10 to 90. We know that this creates values from 10 to 90, and it spaces them out 10 in between, right? So you use that and say, okay, 1 to n, right? K equal 1 to n, 10 to 90 with 10 spaces in between, right? And you can figure stuff out, right? Okay. And now this program here, this projectile program, makes a little bit more sense now. So slowly we work our way up. We learned about plotting, we learned about for loops, right? The computation section started making sense. Eventually, this whole program is going to make sense. And maybe by the end of this class, this slide crank program is going to make sense. And then on the next level, you're going to start writing a couple hundred lines of codes by yourself to do programs. All right, good. So that's all I have for you today. Hopefully you guys learned something, right? All right, so I'll send this to you and good luck on your assignment. I'm thinking about maybe doing a tutorial class Friday for you guys with your assignment. So bring your questions, whatever problem you might have writing code for the assignment, let me know and maybe I can help you out. All right, what do you guys think about doing a tutorial for the assignment Friday? Sounds good?
Yes, sir.
All
Yes,
right,
sir.
okay. So that's all I have for you guys. I'll send this by email, of course, and you guys can take a look at it.
What time, sir, on Friday?
Friday, regular time. What time do we do on Friday?
Oh, I forget we got this class on Friday too.
Yeah, we got timetable time on Friday. So yeah, Friday we can do a tutorial, right? And practice, look at you go. I can send this textbook. I doubt whether or not it'll be useful because a lot of the programs are complicated like this one, right? So I don't know if you guys might like it, but I'll send it and maybe you can use it in the future, right? All right, electrical students, don't leave us yet. I want to talk to you guys. I'm supposed to teach you guys EMT tutorials for mathematics. Mechanical students, you guys can go ahead and leave. That's all we're finished
Thank
for
you,
today.
sir.